Hey guys, today we're going to talk about measurement to prepare you guys for your measurement lab next week. On Teams today, you guys should have had 4 different pictures to post into your guys' 8th grade notebook. So again, we're in the metric system unit. We did unit conversions the other day, so you guys would post those 4 pictures under measurement. If you guys haven't done that yet, go ahead and pause this video, go back in and get those into your notebooks. You guys can kind of add some little notes and highlights and things like that you'll need as I go through. All right, so you guys should have all 4 videos in, or excuse me, pictures in. Your first one is going to be on mass, so we're going to talk about how to take the mass really quick. So you guys will be using a gram scale or a triple beam balance. A triple beam balance is pretty old school, so I'm going to teach you guys how to read one. You'll get a little bit of practice, but for the rest of the year, you guys will be using an electric gram scale, which is a little bit more accurate as well. Okay, I'm not going to show you guys how to use the triple beam balance yet, but for the gram scale, there's 2 really important things for you guys to do is always make sure that your mode is in grams, okay? There's other options for you to be in ounces, ounces by weight, and I think there might even be one more. I don't think there's pound on there, but how you guys tell is if you guys go ahead and grab a highlighter, you guys can mark this on yours as well. Up in... Maybe that wasn't the best choice. I'm going to do a pencil instead. Up in the upper right-hand corner of our gram scale, this is an actual picture I took of our gram scale, you guys will see this little G. That means it's in grams. If it doesn't say G, maybe it says OZ, you guys would click this mode button until it goes to grams, okay? The other thing is to zero the scale. So every time you guys measure something, you want to make sure you're starting out at 0. Okay, there might be some exceptions to this where you guys add something to the scale first and then zero it so it doesn't count that mass. But for the case of most of your guys' measurements, make sure that your scale reads 0 first. If it does not, okay, then you guys will need to zero the scale. So you'll click this button right here and then your scale should start reading 0. Okay, so that's how you guys take a mass on the on the electronic scale. Okay, these right here are just some examples to show you how to work the triple beam balance. Let me kind of zoom in on this a little bit more for you guys. Okay, these are just some practice readings that show you. So what you see on a triple beam balance is there will be 3 sets of weights. You guys can measure by tens. You can measure by 100. So that little weight right here that you'd see on a triple beam balance is 100 grams. Okay, this one's 10 grams. Or you guys can measure this thin little piece of metal that gives you tenths of a gram. Okay, so these are just some practice with measuring. So if I look at the first one, I can see that my first little measurement on the tens is at 20 grams. Okay, my hundreds bar is at 100, 200, 300, 400, 500, 600. And my ones is just shy of 3, so it looks like it's about 2.9. Okay, so it's not quite at the 3 mark, it's about 1 dash. I know that's hard to see in front of it, so we'll go ahead and call it 2.9. Then what you guys would do is add up those 3 numbers. So whatever we're weighing, in this case, has a mass of 622.9, and again, our unit that we use for this is grams. Okay, this one we're going to do the same thing. We can see our tens measurement has 10, 20, 30, 40, 50. This one is set to 100. And this one looks like it's probably about 3, we'll say 3.5 is right there. So we'll call that 3.7. Okay, so you would add those up. 100 plus 50 plus 3.7 is 153.7 grams. Okay, last one. Why don't you guys go ahead and pause this video, see if you can do it yourself, and then come back and check your answer with me. All right, so we can see our tens place is set at 0, so we have no mass at the tens. We have 200 here. And then this one, we are not even a full gram, so there's 1 gram. We're probably about halfway. So that would probably be about 0.5. So this one is going to be 200.5 grams. Okay, and that's how you guys work with the triple beam balance. You guys will be measuring those in class, and again, I'll go through that a little bit more as well. Okay, temperature. This is pretty simple, but there's a couple mistakes that I see kids make a lot. So first of all, we always measure our temperature in degrees Celsius, and you guys will start to get familiar with what degrees Celsius looks like. It is a lot easier if you guys look at water freezing. Water freezes at 32 degrees Fahrenheit, but it's a lot easier in Celsius because it's just 0. It freezes at 0. Okay, in Fahrenheit, water boils at like 212, but with, again, degrees Celsius, it's a lot nicer because it's just 100, and those are a lot easier numbers to remember. Some other things to remember are room temperature is usually about 20 to 25 degrees Celsius versus 65 to 70, and body temperature, we all know is 98.6 degrees, but in Celsius, it's about 37 degrees Celsius, okay? Biggest thing is measuring these. You guys are looking for that little red line that goes down the middle. It's not mercury anymore because that's bad for your health, okay? This is the biggest error I see kids make is you guys have numbers on both sides, okay? So you can see here's a 1 here, and then there's a 0 on the other side. Okay, so this would mark 10 degrees. More often than not, I see kids just look at the one number on the left-hand side and say, all right, I am measuring the temperature of the room right now, and it's 2.7 degrees. So they'll say, oh, it's 2.7. But when you think about that, does that make sense that I'm sitting in my classroom on a September day and it is 2.7 degrees Celsius in here? That's barely above freezing, okay? My room never gets that cold. It's always a sauna in here. So make sure you guys read both sides of the number. So we've got 2.7 is actually 20, and then each of these increments, 1, 2, 3, 4, 5, 6, 7. So it's actually 27 degrees Celsius, which makes a lot more sense. Okay? Length, pretty easy. Use a meter stick or a ruler. You guys will probably be measuring in centimeters, meters, or millimeters, but use what makes sense. So if I'm telling you guys to go measure a bug, you're not going to use meters. That's too big of an increment for you guys to use. You're probably going to use millimeters, or if it's a really gigantic, creepy bug, you're going to use centimeters. Okay? Ask you guys to go measure the distance from here to Great Falls, you're probably not going to use millimeters or centimeters or even meters because those are going to be really big numbers to deal with. You're probably going to use kilometers. So make sure you're using the appropriate unit. Okay? Last but not least, we have volume. So we have a lot of different things to help us measure volume. Our two main units you guys are going to see the most are liters and milliliters, and I've really never used anything other than that as far as volume goes. Okay, biggest thing to remember is you're going to measure to the bottom of the meniscus, and we'll talk about what the meniscus is here in a second. Okay, just some little tips for you guys. This is a beaker. It's really great because it has this handy dandy pour spout. You don't make a mess every time you pour, but you guys can see it only has increments of 500, here's 450, 400, 350, 300, 250, 200, so it's not very accurate. It would be really hard if I asked you guys to go pour me 237 milliliters of something. Okay, same with the Erlenmeyer flask. It's really great for certain things, but it doesn't have this handy dandy pour spout. So you might dribble a little bit, and again, it's only measured by hundreds. Okay, so it's a little bit less accurate even. Probably your most accurate is the graduated cylinder. It has lots of graduations. It's not because it's educated and has finished high school or college, but it's called graduated because it has all these little lines that are graduations, okay? So this one, you can see, I think, just about every milliliter. It's hard to see that picture, but you can get just about every milliliter in there on that. So this is the most accurate to use. Okay, so let's talk about this concept of measuring to the bottom of the meniscus, especially when we're measuring something like water. Water has this crazy surface tension or this crazy attraction between water molecules that allows them to kind of almost stick together. And that's why if you guys have ever seen a water bug just kind of skipping along, like, why does that little bugger not fall in the water? Okay, it's because of this concept called surface tension, the fact that these water molecules are sticky. So you kind of almost have this curved shape, and this is going to be hard for me to trace over. Curved shape line that almost makes like a U shape. That's a really bad drawing. You guys can see it good enough in the picture. This is called the meniscus. Okay, so when you're measuring volume, we want to be consistent of where you measure to. So you always measure to the bottom of the meniscus. If everyone measures to the bottom of the meniscus, then we should all be pretty good as far as where we're measuring. So if we look at this, this is 10 right here, this big line that goes around. And then this is 15, so that means that each of these big lines right here are 1 milliliter. So we can kind of see where all of them are at. So we're at 11, and then it looks like if we go to the bottom of the meniscus, 11.5. So it shows us the milliliter, and also kind of shows us a half milliliter. So you guys can see how much more accurate a graduated cylinder is as opposed to like the Erlenmeyer flask or the beaker. Like I said, these are great for a lot of purposes, but when I want you guys to find an exact volume, use a graduated cylinder. I think that's just about it. Like I said, if you guys haven't already, you might want to jot some notes on here and like to help you remember what a meniscus is, or to use a graduated cylinder to be more accurate, how to maybe read a thermometer, and you should have had some of these numbers written in to help you guys guide you as far as adding up masses for a triple beam balance, and then just to kind of show you guys how to work this electronic scale. Okay, I hope you guys are having a wonderful day, and I will talk to you soon. Bye.